network. Let's turn that on. Alright, and it's 0.1 network, which is on the OSPF WAN, is in IP at 201.68.109, 201.68.109.30. Turn the interface on. Okay. Let's create the OSPF router instance. Tell it to participate in network 201.68.109.128. 0. There. It forms an adjacency with R1. Okay. Now, we have to do the same thing with the IGRP. Its autonomous system is 25 from the topology. And the network there is 192.168.50 class C. But here in an EIGRP, I don't use wildcard mask, I just use the subnet mask. That's all I have to do. But to make it classful, I need to use the no auto summary command. Alright. Alright, so that sets that up. Now let's go to R3. And it's attached to network 172.21.0.0. I'm going to make it .1. Turn that interface on. Okay. And its 0.1 interface is attached to the WAN, so it's to IP add 201.68.109. He's 131. Okay. And he has to participate in OSPF. There it goes. Loads, makes an adjacency with both R1 and R2. Now we have to put the other network in area 1. Say /24. There. Get that to memory. Now if I go to the head end to R1, I do a show IP route. Well, wait a second. A couple things that are missing here. I see the 172 network, but you remember that I have to have full 100% connectivity between all routed networks. Well, what do I have to do to make the internet routable? What did I make you do in Lab 1? A default route, right? Okay, so I have to create a static route. Alright, good. I'll create a static route. So, '97, which is, I think, right? Yep, 97. There, static route. Perfect. All right. Now, I'd do a show IP route. Okay, there's my static route. But what am I still missing? What am I still missing?
The 192.
The 192 network. Correct, Steve. This network down here. What?
Is that where you have to redistribute?
I have to redistribute, right? So, where would I redistribute? Which router?
Router 2.
Router 2? Yeah. That looks right, because that's where your border between the two dynamic routing protocols are. So go to router 2. Now, which routing protocol do I do the redistribution command? EIGRP or OSPF?
Yeah, GRP.
Wrong.
Okay,
Yeah, 50-50 shot, right?
yeah. OSPF.
OSPF, because I'm telling OSPF I'm telling the router in OSPF, take the routes that you've learned from EIGRP and inject them into OSPF. Okay, so router, OSPF 100, redistribute, EIGRP, the process ID with our AS, which is 25. Alright, from here I can hit enter, but it's good practice to define a metric, which I'm going to keep simple and just give it a metric of 1. It's just a variable. It's no different than just hitting return. But I also want to use the command subnets so that the networks that it learns from EIGRP are redistributed classlessly. Okay, not on classful boundaries. Not on classful boundaries. I do that. Now, when I go back to R1, I do a show IP route. Now I see the 192 network. Right? Pretty cool, huh? Wait a second, though. Let's take a look at R2. Okay, R2, I see the 172 network. It's an inner area from OSPF. I see my connected. I have that. What do I not have in R2?
The static route.
The static route. Why don't I have the static route in R2? And I bet you in R3, if I look at R3, no, I see the 192 network now, but I don't see that static route either. What have I not done?
Is that a redistribute too? You have to set a static route on each one.
No.
Redistribute?
Well, you could set a static route at each one, yeah. However, that would defeat the purpose of the dynamic routing protocol. I have to redistribute the static route from R1. Now, in most routing protocols, RIP, EIGRP, ISIS, BGP, you just have to go into that routing protocol and say redistribute static. OSPF is a little bit different animal. There's a special command that you have to do. It's called default-information space originate. So any originating information from that router in the form of static routes gets redistributed within the protocol, and it will be injected as an E2 route, so it will be picked up by any other redistribution throughout your domain. Default-information space originate. Once I do that, I go to R2, show route. There it is. Took it a second for it to populate. Alright. Wow, all that work for question 1 and question 2.
What was the command again?
I didn't get that other command down.
Default-information space originate under your router OSPF process. Next, block any routing for RFC 1918 networks to the internet. So I want to put that access list close to the internet and block it. I could do it on R3. That wouldn't help me with R2. You could do it on R2. That wouldn't help me with R3. So at the head end here at R1 is where I want to put it. Same exact list that you did from LAB1. I'm just going to do the first couple ones here. So I want to make a access list standard. Access list 10 permit 10.0.0.0 access list 10 permit 172 I'm sorry 192.168.0.0. I'll let you figure out the third one. What do I have to put at the end of this access list? All of you got it in Lab 1. What do I have to put at the end of it? Permit any. Because if I don't, what's going to happen? I'm going to block all the traffic, right?
Didn't you permit everything anyways? You permits, not denies.
Ah! Critic. It's late. There. Then I have to go and apply it to an interface, right? So the best interface to permit it would be on the inside. So 0, 1. IP access group 10 in. There. So make sure you get all the 1918 networks, all the private spaces. Because I only did one. I'm not going to give you guys everything. Re-IP, we already did that. Just be very cognizant of it. Now, NAT. As I get older, my brain power decreases. So I often have to rely on Cisco. Okay? And I got this from this webpage, IP Address Configuration Guide, Library, Cisco iOS Release 4.2. IP addressing and NAT. Okay? Configuring NAT for IP address conservation. Okay? And explains how NAT works. Under how to configure NAT for IP address conservation, you want the static translation piece. So, in R1, what you need to do is IP NAT inside source static. Local IP or private IP to global IP or public IP. There's my IP pair, my first IP pair. IP NAT source static 92.168.50.4 201.68.109.137 enter. Okay. You need to repeat that process for all of your static NATs, B through E. Then go into your interfaces. 0, 1 is my inside interface. It faces OSPF. So I'm going to type in IP NAT inside, defines my private space. Then if I go into interface 00, which faces the internet, it's the outside or my public side, I'm going to type in IP NAT outside. Port address translation. Now, I can use port address translation a couple different places. I don't have to do it on R1. I can do it on R3 because it's closest to those workstations. Still be routable. I still have public IP space there. Or I can do it on R1. Doesn't matter. Yeah, that's one of those areas that you can do it either one. But specifically here, I think I tell you to do it on R1, don't I? Yeah, tie it to R1 serial interface. So on R1, I need to do a port address translation. So to do that, I would do IP NAT source list I have to define an access list in order to find the interesting traffic of the source IPs I want to identify. Now I can do a numbered access list, or I can do a named access list. I'm going to show you how to do a named access list tonight. So I'm going to name this access list Pat. Okay. Interface, I'm going to tie the global IP to an interface, in this case Fast Ethernet 00. And I'm going to tell it to overload that IP. Meaning it's going to allow multiple outside connections. Now I have to define the access list. So I do that by typing access list, IP access list, standard, because I only have to apply this to source IP. Then I give it a name, Pat, which will match the NAT statement. I hit enter. My prompt changes to an access list prompt. I'm going to type permit 172.21.0.0 wildcard mask 0.0.0.255. I'm done. That's it. I don't want to permit anything else, just that network. Right here. That network right there. Write often. Write very often. Write extremely often. Save all your stuff. Next. Pat. Okay. I'm going to stop there for now. I'm going to work on this VM. So if I go back to my GNS3 topology, you see that I tied my VM here, right? Now hopefully, if I did this right, I can still ping myself, yay. I gotta figure out which network that's on. Fun. Okay, let's try this real quick. Beam player is a little bit trickier because they don't let you set up stuff automatically. How do I want to do this? See what I can break here. Didn't work. Oh. Oh well. Alright. Really hate VM player. Alright. Forget this. Go back to workstation. Because I got that one to work. In brief, you've got to get connectivity between this cloud and the Ethernet interface of R2 in order for the AAA traffic to work and for the router to be able to send information to the server for authentication for AAA. Okay. Alright, so now, very important step, that you need to understand, because if you ever have to give up on a project at night, test or lab or whatever, you need to make sure you save your project. So I started a brand new project at the beginning, so all I have to do is click save, see all 3 router configs come down, I go into my temp file, and there's all my configs. Date modified. So now all I have to do when we come back on Thursday to finish this up is go into each one of those individual folders. I got through this so much faster with this class than I did the last class. I don't know why. I think I just did better practice, better drilled. I stumbled through a lot of stuff from 6 to 8, I guess. You're smarter? Yeah, there you go. Steve hit it. You guys are just smarter. Have any questions? Alright. I will see you on Thursday. We'll go over attack vectors, and we'll finish up Lab 2, the walkthrough of Lab 2. Still planning on having a guest lecturer next week. Bye. Do you guys have any questions for me?
Well, are we giving tests next Tuesday?